Hey guys, Mr. Gardner here, and today we're going to look at interpreting line graphs from functions. So our objective for this lesson is I can interpret a line graph and describe it based on its qualities with 80% accuracy. So again, we want to talk about qualities and what they mean. So we're just going to review really fast, and we're going to talk about what we went over pretty much all of last quarter. So let's talk about y equals mx plus b. This is our linear equation. Okay. And they call this slope-intercept form. And that's because you're given the slope and you're given the intercept. So when you're trying to put it on a graph, you can use those pieces of information. So again, m is going to be our slope. And it is the change in the y values over the change in the x values. All right, so the vertical versus the horizontal. Okay, we've called this rise over run. All right, so you got to go up before you can run. So vertical versus horizontal. All right, and another way we've described this is also calling it the rate of change. Okay, and it's like how much something changes over one interval of time or whatever it may be. Okay. Next thing I want to talk about is that b value. That's our y-intercept. All right, what that means is it's where your line is going to cross through the y-axis. So you can see in the picture we have over here, it's 0. The y-intercept is 0. And on some different ones, it may be positive, it may be negative. So if it's, let's say this is our 0, 0 point here. If it's above that, right, that's going to give you a positive y-intercept if that was the line. And let's say maybe it was down here and it was going that way. That is going to be what we would call a negative y-intercept, right? It's below 0. So if we're thinking about that, this would be a case of something like y equals 2x plus 4. And this one down here might be y equals, 1x plus negative 4. Okay? Or that could be written as x minus 4. But I always like to put things in plus the negative so that we can see that this sign actually goes with the y-intercept. So that's really important to see. All right, and the next thing we want to just remember is that our y and our x values, this is going to be our dependent variable. Okay, it depends on this x value, which is our independent variable. All right, so we usually manipulate this value here to get different values of this y value. All right, you can think of it in a table as well. We got our x values first and our y values, and we change these values to see what the y value is going to look like. Normally, if we're given the y value, it's so that we can solve for the x. Okay? So that's just a quick review of the stuff we did last quarter. And now I want to talk about how we're going to apply that understanding to the object of this week, which is being able to describe these linear graphs and show what they mean. So the first thing you want to do is you want to just look at the graph. All right, I see this graph. All right, and I want to look at first what my x and my y axes mean. So I see here my x is in time and my y is in speed. All right, and so that's going to help me make sense of what's going on. And I can make a little table, my x and y, and if I want to label it time and speed. All right, then I can just start looking at it from some intervals. So I know that this is, and I didn't really explain that, but this is a bus that's moving. All right, this is the time it's moving, and then this is how fast it is moving. So we can think about this, right? Is at this interval from 0, 0, so it starts at 0, 0. So that makes sense, right? It hasn't moved yet. It's not going any speed. But as time starts to pass, we can see that it is starting to move. So we can see this point here, A. All right, and I would just extrapolate by just looking at that that's about halfway. So that's probably 5. All right, and so after 5 seconds, it is now going 10 miles per second, which is pretty fast. It might be meters. I'm going to go with meters. So 10 meters per second. All right, and we can see that because this is positive, then this slope is positive. So if I was thinking about that, right, if over time and it's going up, then that would tell me that in that interval, All right, so if I was going to describe this, I would say bus is speeding up. All right, and then we look at the interval from A to B. And we can see that from 5 seconds to about 10 seconds, nothing happened, right? We're not going any faster, but we're still staying at this speed. So no change. Okay, so what do we think's happening if there's no change? Are we still moving? Well, time's still moving and our speed is still happening, but our speed is staying constant. Okay. So we could say here, so this is going to be from 0 to A. All right, the bus is speeding up. From A to B, I would say the bus is just cruising. Right, it's reached its speed. It's not going any faster. It's also not going any slower. It's just staying the same. There's no change here, right? So this would be like a slope of 0. There's nothing going on here. So cruising along, we can call that. And we could say at 10 meters per second because it does still have some speed. Now we can look from B to C. From B to C, what's happening here? Well, now it's starting to decline. Okay, so it's going that direction, so that we know that's negative, right? It's moving in the opposite direction as positive, so it's going negative. And over these, it's not a very long interval, 3 seconds. It goes from 10 to 0. So if I'm thinking about that and making sense of it, I would say that if it was going at 10 miles an hour and now it is going 0 miles an hour, the bus is braking. All right, so the bus is slowing down now from here to here. Okay, so it's slowing down. You can see every second it's getting a little bit slower, getting a little bit slower, a little bit slower, a little bit slower until it's at 0, which is usually a stop. If it goes to the negatives, that would mean maybe it's going backwards. I don't know what negative speed is. So, okay, and then we can look now at C to D. This is that flat space again. So we can look at what we said here. Nothing's changing. And you can kind of do an inference here from C to D. And you can think about what it means if you're driving and you're at 0 speed, but you're just sitting in the car, not moving for a period of time. You are stopped, right? So probably at a stoplight, or you're at a bus stop, maybe. Could be the bus stop. So stopped at light or bus stop. All right, again, we're just trying to make sense of the graph and what's showing us. Now again, at the 16-second mark, the speed starts to go up again. Okay, we know that's positive because it's going in that direction, so it's rising and running instead of dropping and running. So again, we could say from D to E that this bus is driving again. Bus is driving. Or accelerating. That's probably the better math term, accelerating. All right, so it's accelerating, it's speeding up. But now look, it speeds up to E. So from E to F, again, we just want to think about this from E to F. It's that no change, so 0 change. And we have that same thing here, no change. So again, what do we think it's doing? It's probably just cruising along. But is it going as fast as it was before? No, it's going about half that speed. So maybe, I mean, if we want to just get more detailed, you can make up any kind of story you want, really, as long as it makes sense. Maybe at this A to 0 to A, maybe he was getting up to the freeway, right? Because you go faster on the freeway. Then he cruised on the freeway. Then he got off the freeway, stopped. Then he sped up a little bit on a regular road and then was just cruising on the regular street. So we could write a whole scenario for that if we wanted to.